we're ready to continue on with a really interesting topic of industrialization of construction. How are the challenges? How to address them? What it even is. I'm just going to set the context, and then we're going to turn it over to some experts in the field who flesh out this theme for us. We're going to hear some practical applications, and we're going to be a little bit provocative. So last year, the Construction User Roundtable put out an article about, is construction ever going to get with it? Are we ever going to have modern production in construction? But that, kind of begs the question, well, what the heck is modern production? Is it the movement of work off-site? Is it either moving it near or far? Is it standardization of designs? And how does what does it really mean for construction? Is it modularization? And by construction, I mean everything, the whole process of designing and building capital projects. And is it modularization? It's kind of the rage right now, thinking, oh, if we modularize, we move it to a more controlled place to fabricate things together. We can avoid a lot of pitfalls, and we call that modern construction. Or is it, I call them declared factories. You see them popping up all over the place. I have a well factory. I have an offshore platform factory. I have you name it. I have an onshore separation factory. And is that what it means for construction? Or is those just really a replication of standard designs? So when I started doing some deep thinking about our project system, and I wanted to see, and I wanted to understand what others were doing, I met with a whole number of companies outside the energy sector about what they do, how they did it, especially how they did product design. Met with companies like Apple, IBM, and as you can see, met with the Ford Motor Company. This was probably the most impactful of all the visits we had. So what in the world could Ford and Chevron have in common? And we found to start with that they wanted to understand how we make big bets in the energy sector, how we make those big decisions. And we want to understand how they did product design, how they did our product development, and how they did manufacturing. So as we sat down and talked, we found, man, we have a lot in common. We make big financial bets, both companies. You have to make a decision and then live with it for a long time with over many, in their case, millions of vehicles, in our case, a major investment. We're both highly regulated, extremely competitive. We have to all spend a lot of money to create new products, and it's very supplier intensive. We're not in this alone. So got to go to Dearborn, and it was really quite amazing to see what modern production really looks like. Everything from soup to nuts, everything from a screw design all the way to how they do quality checks with the F-150s coming off the production line. It was really quite impressive. And I just came back with a treasure trove of insights and observations about what we saw. I'm going to talk about those for a few minutes before I turn it over. So first off, we started talking about how they do product design, and they started talking about their basis of design and the BOP. So what the heck is a BOP? I said, well, it's our basis of process. I said, okay, what the heck is a basis of process? Never heard that term before. And they said, well, that's how we're going to make the vehicle. So in their system, they have a basis of design like we have. It's the technical basis for what some facility we're going to have, but they put alongside it with equal weight how they're going to make that vehicle. And there's tension between the two, but they work those two through the whole life cycle of that project. Basis of process. That's how it will be done. Totally missing from our industry. And then that results in a complete bill of material. Literally every screw, every bolt, every rivet is accounted for in the design from point A to point B. None of that. Everything is designed completely. What a difference. They design to a cost. They have a really good cost structure. They understand what it costs to make things, and they set a cost target for a particular vehicle and satisfy the customer demand that they envision, and they design to that cost. And everybody is focused on it. Again, there's a lot of tension there between the basis of design and the BOP, but everybody's designing to that, and they're designing the manufacturing process in parallel to get to that cost point. They reuse standards. What you see and what the uniqueness is. But behind that, like if you got a compressor, you have three to choose from: a big one, a middle one, and a little one. And they expect you to reuse that design. They reuse as much of the things behind the scene, under the hood, under the frame that you can't see, you never touch, as possible. And that allows huge efficiencies in their system. They even have corporate metrics on design reuse and standards. Another huge difference is they do their own engineering. They probably have something like 80% of the own engineering, and they'd have about 100% if they could. Some of the things are proprietary, or they've got supplier engineered parts. So they gauged about 80% of their work was engineered. Huge difference. Full control of the engineering that goes along with their vehicles. Integrated suppliers, holy moly, they do something really special that I've never seen in my life. They have a very good handle on the should cost. So the cost is really a minor deal. The commercial agreement between the two parties is very simple. It's not complicated with liquidated damages and complex incentives and all that stuff that we've gravitated to in the energy sector for sure. So it's very simple. But what's important is the way they've integrated the design of what the suppliers do into the overall design of the vehicle. So it's a fully integrated approach, fully integrated production, part of the production system. Ford has some 800 people sitting in the suppliers' offices around the world, ensuring this close coordination, ensuring this close work, and really making the supplier a part of the Ford family, if you will. And they really take it seriously. One supplier has a problem, other suppliers step in to help that supplier. They all win together. It's a surprising or an amazingly collaborative environment and cooperative environment, not commercially driven. They have one digital platform. Of course, they have hundreds of programs they use to do particular things, but everything is integrated into one digital model, one digital platform. Everybody has one source of truth, whether that's themselves or their suppliers. Everybody working together. I mean, this is starting to blow my mind at this point to see what they're doing versus, we look like cavemen compared to this. That digital platform even is connected to the ability to completely virtually build a vehicle. So they simulate the fabrication or assembly of their vehicles using their BOP and make sure they work out the kinks on how do they build it in advance. They even crash test a car. I said, wow, you crash test it. How do you do that? How we wrote program to do that? Because it's expensive to crash test cars. And they simulate maintenance so that later on people can actually maintain and get to the bowl plug for the oil and what, all the things that a mechanic has to do later on. Total virtuals. They have a really good handle on how they're going to make it, how this vehicle is going to perform and be maintained over its life. Then they build one. They build a prototype, and they say, okay, they learn a lot from that on actually testing out the things that they've planned in the digital environment. Then they make about 40 vehicles, and they take them for a test drive. They work out a few more minor details, and then they go into mass production, creating thousands or millions of a vehicle. So we spent a good share of time with the people that do product design, and that was kind of what I just ran through really quickly. I got to say that it was really quite amazing whether we talked with finance people, the head of their engineering group, the head of their supply group, whoever it was. They all understood vehicles. They're all motorheads. They all understood the business of making a vehicle that satisfied a customer and would give them a return on investment. It was really, really quite amazing. It wasn't a very siloed organization at all. And then we got to see the line, went out to the F-150 line, and that again was just totally eye-opening. I had no idea that every vehicle coming down that line is unique. Every one is made to order. And they're not like we make a batch of this and we make a batch of red ones with these certain features and we make a batch of white ones with these features. No, every vehicle coming down that line is unique, made to order, which means when the worker turns around and picks up the next part for that vehicle, it's got to be the right part that matches that order, whether it's the red or the blue or the leather seat or the vinyl seat or whatever it is. It's got to be the right part for that particular order for that vehicle. And it's got to be reliable. Every time they turn around, 100% of the time, it's got to be the right part. And that which ties to the inventory management. And it's, I was on overload at this point because it was so different than what we did in Chevron. They deliver roughly 1.6 million parts to that factory floor every 24 hours. Stop and think about that. 1.6 million of the right parts, of the right models to make those unique vehicles so that they can produce one truck every minute coming off of that line. Now, I had to think, if that was Chevron, we'd have 2 years of parts sitting out in the warehouse. They do it with 5 days, and they think that can be improved. 5 days of inventory, and this stuff's sourced from all over the globe. It's not like everybody's just down the street in Dearborn. Stop and think about that for a minute. I mean, these people live in a world that is so different than the world I was living on, and it was almost overwhelming to figure out where to start. And again, everybody is focused on factory throughput, one F-150 every minute that met quality requirements, quality expectations, and that's the flow. It was interesting that we're standing around watching the guy, the people work on the line, and some of them were checking, they're doing some texting, talking on the cell phone, looking at websites, waiting on their turn for the next vehicle. Productivity was, I wouldn't say low, it was just relaxed. And again, if that was us, we'd be whipping those people. You got to find something else for them to do. Can't they be doing something else at the same time? Look at all that dead time. No, none of that mattered. It was all throughput, flow. If that meant people were standing around waiting on the next thing, fine, because they weren't going to build up unnecessary whip in their system. And, the other thing that was just obvious as we talked to everybody as we went through this is how fluid they were in operation science and the concepts that go with it. I mean, they live and breathe whip. They live and breathe tack time. They just live and breathe all that stuff. It's not like a debate or a conversation about how did you apply this? How did you apply that? They're just doing it. And instead they're building more and more efficient. They thought they were kind of average. They looked at Toyota as the best of the best in how they do this. And they're striving for continual improvement and using technology and improving their methods. It was really, really quite a special thing. And we brought that home and started saying, okay, what do we do? Taking all this at once is just trying to bite the elephant at one time. And for me, it just kind of got focused on, well, let's come back to the beginning, the basis of process. We need to be very focused. We start being very focused on sorting out how we're going to do something and holding that in equal weight to the basis of design. We need to design to a cost, design, reuse, and standards. We need to narrow the field on how many different engineering companies we work with so that we can work out issues with them. We need to get away from these complicated commercial arrangements and instead have simple arrangements that allow us to work together with our engineering companies and suppliers. We need one digital platform, and that's just the beginning. So those are kind of my takeaways. It was really insightful, and I think now we're gonna have the opportunity to hear from an expert in the field of how to take taking a deep dive on concurrent engineering. So let me move on and introduce our next speaker. So Bluetooth, can you turn your video on? There we go. And let's see, I've got to figure out how to stop sharing somehow. Somehow the right screen just went away. There we go.
Right. Let me share.
Okay, so let me introduce you. We're going to take a deep dive into now how concurrent engineering is really done. Just because the product's unique doesn't mean you can't industrialize. So Amutu, welcome you. I'm not even going to try to pronounce your last name. I practiced it, and I know I'm going to butcher it, so I'm just not even going to try. I'm sorry. I don't want to offend you. But Amutu is responsible for designing and developing industry solution experiences for the energy, materials, and customers at Dassault Systems. He has like 25 years of experience in product management, consulting, R&D, and market intelligence. He's been a trusted advisor to customers and organizations in industries ranging from automotive, aerospace, and now the energy sector, with a strong acumen in digital manufacturing and product lifecycle management. He's worked and lived in India, Japan, and currently calls Detroit his home. So we're in good hands here. If you could turn on your screen and share your thoughts with it, I'd appreciate it.
Sure, thank you.
Okay, we can see your screen now. It's all yours.
Perfect. Thank you, Gary. I hope you guys can listen, hear me well too, right?
Yep, hear you just fine.
All right, great. Thank you, Gary and SPS. So modern day factories, as Gary has stated, it's awesome. It's so interesting to watch them hum and function like worker bees. And just like Gary, I had the fortune to visit the Toyota factory in Japan, the Numi factory, the Tesla in Fremont, California, as well as my good old River Rouge plant from Ford. So everything is self-contained. Everything is designed as though they are the best in assembly line efficiency. So thanks for joining us today to talk about this high volume production and how automotive companies do what they do best. So before we get deeper into the automotive analysis, a little bit on cross-industry comparisons, right? So if you look at the chart, high volume industries like aerospace, automotive, in the last 2 decades have digitally transformed, as Gary alluded to, by having a common platform, etc., digitally transforming their engineering, manufacturing, simulation processes to the tune of they are able to get their takt time, as Gary alluded to. Takt time is nothing but the heartbeat of a production process that's humming. So Toyota is able to, Toyota-like companies, Toyota, Ford, and the likes, they're able to shrink their takt time up 75% the last 2 decades. And cycle time, similar measure in the aerospace industry, they're able to crush them up to 55% the last 2 decades. And as a result, Toyota is able to put out a car every 58 seconds. And a Boeing is able to produce a 737 once in every 8 days. And looking at our capital intensive industry, construction puzzles specifically, so we applied similar routes. We tried our operational excellence, lean transformation. We relied heavy on engineering innovation from a hardware perspective. Then we also implemented some behavioral changes, maintenance procedures, etc. But since 2000s, although the investments went high, complexity of projects grew manyfold, but the ROI and the margins have started going in the other direction. So what can we learn from these digital transformation, and how can we apply, take a book or two from their, take a page or two from their book and apply it to our industry? So let's start with the transportation industry, where I have had the pleasure and honor of working in my previous life to the same employer, by the way. So what you see on the screen is a typical vehicle development process. So this covers a vehicle all the way from a vehicle concept to end customer, a full automotive story, right? So it starts with the concept. You want to do an EV, you want to do a sports vehicle with such and such trim, 0 to 60 in 3 seconds, 4 seconds, come what may, whatever the USP is. Based on the customer demand, they come up with their S&OP, or sales and operations planning, at the very early stages, sort of matching what my customer demand is in the next couple of quarters to a year, and how my supply network is, etc. They balance all this and come up with their S&OP plan. Then the engineering and design folks starts into action, and they start doing their system architecture, vehicle modular architecture. Modularity is key. As you see, I'll use that term several times in this presentation, because they want to produce many models, many options, as Gary saw, as much as possible in the same line. So that is your efficiency. That's how you achieve efficiencies. You could have many common parts, and you could have several commonality between these models. So the more you modularize them and the more you standardize and put them on the same line, the maximum efficiency you can get. And the next step of the process, I'm not going to be going too detailed into every section of the process, but we will focus on a couple of those key items and even take a deeper dive with some examples and demos on few sections. So these days, we know electronics and software is in the car. I mean, basically, Ford started calling it's basically a computer on 4 wheels, right? There's so many millions of code and software that go into the making of a car, as well as the electronic part. And on the right, you see the simulation and various multi-scale, multi-science simulation that has to happen in tandem. I mean, these days, many of these OEMs, like the Ford, the Chryslers, and the GMs, they even have a common group called ModSim. So Mod stands for modeling, your 3D CAD model, and your design, your engineering group, working hand in hand with the simulation group. And thus, this ModSim group is formed, and they work concurrently throughout the process. So you will also see the concurrent process working in various phases of this vehicle development. And then you go down, then you integrate your suppliers as the next vector, you do your manufacturability analysis, and so on and so forth. So let's take a little deeper look into the engineering and vehicle development process, right? So I apologize for this complicated chart. So basically, every OEM look for economy of scale. Products are becoming more and more complex, and companies recognize that product personalization is critical to business success. Just like what Gary called, you might want a red color vehicle. I want a sports version of that with the leather trim, with such and such interior, with the best Bose speakers and whatnot. So that is one person's choice. So thus we enter this world of configuration, creating personalized vehicles per customer. So what you see at the middle of the chart is this engineering bill of material that even Gary alluded to at the beginning of the meeting. So bill of material. So engineering bill of material, it's just not about CAD alone, right? So You got to bring in the metadata relating to the configuration, the model, the options, what should be produced when. And at the same time, you don't want to be creating data duplication. You don't want to be creating data silos, right? So as much as possible, we need to represent this information in one common structure, but it's configurable and it's shareable, so on and so forth. Model-based system design is a term that you see that you hear a lot in automotive as well as aerospace industries. What does it mean? You want to model what you want to create, right? In 3D, in a common data structure, and you also want to model how you want to create that bill of process, or we call them manufacturing bill of material. So there's an engineering bill of material to which there's a manufacturing bill of material, which is an answer. And as you can see, the requirements, the functional representation, the logical representation, which is the configuration, etc., of your vehicle, and the physical representation that you see on the right-hand lower corner, which is where the CAD and those designs are built into the same data structure. So now you have a configurable data structure that is not only containing all the information you need, it's shareable across various groups, like the simulation group that you see here. So what you see on the screen, it's basically design and simulation people working in tandem, right? So from a CAD model that was generated, the simulation engineers are able to create a finite, accurate representation of a finite element model. Now they can use that to do crash testing. Not just it tells you the structure, the crumple zone, the various factors that you can test very well in advance before you make even a single part. You can do the structural analysis, your strength analysis, and make sure the human that's riding in those vehicles are safe. Would they be able to take that kind of a jolt, right? So this method of working in tandem, creating your CAE or simulation models in conjunction with design happens very, very early in the process these days, before if any product is built. And the simulation doesn't stop there. You can do multi-physics, multi-dimensional simulation. I just want to highlight one more commonly adopted technique, like the additive manufacturing. A real stock part that you see here, which traditionally used to get into some part of a vehicle, now can be lattice designed. What did we do? We just took that stock part, they just created a lattice network of the same. It does the same job. Performance is not any degraded. It uses the same material in it, but it's much lighter. The so-called light weighting is achieved here. Additive manufacturing, light weighting, and you can do your simulation and stress analysis right on that same model and send that information back to design. Now they can build that according to their design. So this whole concurrently, they can do this work in the simulation group, and the modeling group can work hand in hand before even you get into the manufacturability analysis. Concurrent engineering at play. Now I want to enter this other, my interest and passion is the digital manufacturing. How a manufacturing engineer, manufacturing planner work in tandem, work in conjunction with the design and simulation group. So a good production system has to have, it has to intersect all these various axes of production problems it's thrown at it, right? So what you see horizontally is like a PLM axis, we would call. Basically, the designer comes up with this engineering bill of material with the right configuration, model, etc. that needs to be built. The manufacturing person picks that up, or planner, or manufacturing simulation engineer builds their manufacturing bill of material or bill of process, account for the same configuration, effectivity, etc. And they send that information to the shop floor. That's one axis. The other axis you can think of is like a person walking into a shopping mall these days and ordering a Tesla. It just comes in, the order comes in, the ERP system picks up. A good modeling or production system tool extends the capability of an ERP system and comes up with the right production plan, the right production schedule, who has to do the job, which tools I need to use, etc., which sequence, and so on and so forth. Ends up sends that sequence, adjusted, optimized sequence to the shop floor. Then, as you see, the automotive and aerospace industries work with various tiers of suppliers, and they bring their parts in. Many times they have to make a decision of should I make or should I buy. So whatever items they don't want to make in-house, they end up buying. Like if you look at 787, Boeing 787, majority of their systems, subsystems, and parts are outsourced. They just have in Everett, Washington, they just put all these final assemblies together in what makes a nice plane. So a good production system ideally should do all these on a single platform, a single digital platform, as Gary alluded to. And if we can do the whole thing from design, from simulation, manufacturing, all in this on the same platform, it's much more powerful. So how do we do that? The production system part of how do we do the digital continuity, right? So we layer our manufacturing or production system over four subcomponents. So we model, we collaborate. Collaboration, you already saw, the whole vehicle development process is a collaborative endeavor. So modeling could be the physical representation of the line that is building your product. It could be a welding line, could be a paint line, could be your door subassembly line, so on and so forth, or the final assembly line where everything comes together. And on the right, you see an optimized plan sequence, optimized for a particular variant that you're building. And the rubber hits the road when you do the performance of this, when you execute these activities or processes that are laid out much ahead of you, upstream rather. And the real power comes in when you can not just simulate and model a resource, which is a tool, a robot, a fixture, etc., but when you can scale that up to a work cell level, to a line level, to an enterprise, an entire plant, entire value network, if you can model, optimize, and execute them in a single system of record, then that gives you the maximum efficiency as well. So moving on, let's take some examples of how a typical automotive industry takes benefit from a fully functioning, in this case, a line. So here, in this example, we see a production system that's building, driver's car seat. And you see various machines working in tandem. You have your robots, you have your material conveying systems, you have the human, etc., etc. So using tools like a factory flow analysis, you can study a machine's KPI, a human's KPI, a robot's KPI, and you can look for bottlenecks, and you can analyze various failure rates, if you will. MTBF can be analyzed, mean time between failure. And what happens when a machine breaks down? What kind of an inventory you'll be building up, and what will you end up with when it comes to a broken resource or a temporarily shut down resource? How can you reroute your production operation? So all these types of what if analysis can be done well in advance without stopping a line, so that when you make your first product, I mean, you see there's a red coming up, basically a machine failed here, and you can do various analysis, like from a resource perspective, from a conveyor perspective, from an inventory perspective, what is your cost? So moving on, from a subline, from a smaller level scale system, you could also think of doing that in a much, much higher, full-fledged plant perspective. So all the pictures and the videos that you see here is the work created using software. So they might look pretty, but it's right now it's showing a final assembly line with in the interior panels and the seats being assembled and the steering column. And although they just look pretty, it is talking about how to do your trajectory analysis, a collision-free path plan. What happens if this one robot starts working with the other robot? Would I collide with the other robot? And what is still my optimal sequence? And physical world collision can be very, very, very expensive. And not only that, we can program these robots digitally. So doing all that work on the same system brings efficiencies. And without stopping a line, you could do a complicated engine mount assembly or e-motor assembly, which is usually a difficult thing to do by a human, and it's heavy, it's not reachable, etc. You can extend those type of analysis to a humanoid, human ergonomics here, for example. You can look at what they view. You can get that vision. Is it accessible? Is that under EULA regulations? Are they over fatigued? What do they see, etc., etc. All those analysis can be done right in the system. And as you see, nothing is done perfect first time, right? So here we are showing a change process. So a bracket needs to be swapped out because of some various reasons. Manufacturing asked me to change it, and now we are changing that. So a new bracket is changed. If you, as long as you work in the same system, now you can do the impact analysis in a manufacturing bill of material. What you see here in these tiles are these manufacturing little stations and processes and activities represented. And you can take it down further to an assembly context that we just saw earlier and see what is my impact and how do I respond to this change. And all these things happening virtually, digitally, very well in advance. And you can extend that to your machining, your 3-axis, 5-axis machining, be it additive or the traditional machining shops. So basically, with such a digitally connected modular system, with many virtual runs in advance, you are still able to get a good quality product the first time, most of the times. So and you can scale. And jumping on a little bit from a McKinsey report that recently saw, just to summarize, we can do something similar in the construction industry. And you can think of cycle time, like an operation science principle. And this report also called for, it is time to bring in this productivity and data visibility issues together and try to unlock these efficiencies by integrating them together, preferably on a common platform, so that the further growth of these technologies can be made easier. So just before we depart, summarize, digital information has really helped the automotive and aerospace industries to achieve what they have done so far, and they keep extending that using simulation, manufacturing, and various analysis in a same platform, in a same tool, ergonomics, etc., brings you much more benefits, like automotive has done time and again, and they still want to be improving more and more. If you do them on a single platform, it is still much more effective. So just a bit of legacy, who we are. I work for Dassault Systems. So we were known for our PLM products and what we digitized, and we did a DMU of the first Boeing aircraft to Toyota, to Ford, and then Tesla, and all modern EVs use our software to to do their validation. But more than that, in the last 8 years or so, we also brought everything together into a single experience platform called 3D Experience Platform, where we are able to serve not only the high volume industries, but also other growth industries like the energy industry, the life sciences industry, and so on. I started applying my digital manufacturing principles into my energy and materials industry customers. I'm really passionate about, and really thank you, SPS and Gary, for this opportunity. Thank you.
Okay. So maybe we can bring my video back. Start my video. There we go. Okay. Well, thank you. Boy, that was that always gets me jazzed up every time I see what's possible. And I just have no doubt what you laid out there is the way of the future for the types of things that we're involved with in creating. The idea to be able to virtually construct something and wring it all out, sort out how we're going to do the work well in it, before we ever cut a piece of steel. Wow. I think we'll get huge efficiency. So thank you very much for taking the time to give us that presentation. And now we want to move on to our next presenter, who's going to be a little more provocative, and we're going to explore the construction's use of craft-based approach to production and why it's remained the standard. I'd like to introduce Todd Zabel. He doesn't need much of an introduction. He's kind of the brainchild behind a lot of this, and we're really pleased that he's got some deep thinking to share with us here. If you haven't met Todd, he's the founder and president of Strategic Project Solutions and the founder of the Project Production Institute. Prior to SPS, he founded Pacific Contracting, which was recognized in the mid-90s for its use of various innovations, including lean construction and virtual design and construction. And over the past 2 decades, Todd's authored numerous papers on the topic of optimizing engineering, fabrication, and construction. And he's got some great insights and thoughts to share with us today. So Todd, I'll turn it over to you.
Okay, thank you, Gary. So we ponder the question, what type of production is construction? And we're going to take a little bit of a trip down a road that's not fully jointed, but hopefully there's some nuggets in here that you'll be able to take away. So starting off here, it seems that in our discussions and observations within the engineering and construction industry and its customers, owners are frustrated. There's a lot of talk amongst owners about we're going to move to a factory model, make this stuff off site, get it out of here. I've been told I'm not going to have the necessary labor to do the work that I need to do. We need to standardize, we need to modularize, we need to do something. And so what we've seen is a lot of discussion recently on this idea of factory models and build off site. I can't tell you how many times we hear we're going to adopt the factory model. It's a factory model. What we're doing is we've moved to a factory model. And as Gary asked earlier, what actually is a factory model and how do you go do a factory model in construction? I think so far today we've had a fair amount of insight into that topic. For others, they call it simply as modularization. We're going to go do build this job using modularization. And as probably not as bad as the software industry is, the construction industry likes to take words and twist them into things that fit what they want to describe. And I'm not certain modularization is necessarily a good word. So we're going to propose a little bit later that it really gets down to automation and where you do things. Okay. So much to the point where CII, Construction Industry Institute, has through, I believe it was research team 283, came out and with a report, and this is, I think, a version 2 of it, talking about the benefits of modularization. And it's interesting in the total installed cost graph, they say that it's going to cost you a little bit more money early on, but of course, as CII always does, in the end, modular is going to allow you to cost less. And hey, it might even go faster. So, who wouldn't want to do this? But I must say, I'm enamored with the Construction Industry Institute. We call it by the people for the people. When we ask major investors in capital infrastructure, what benefit are you getting from a cost and schedule perspective from modular, they simply say there is no benefit. We do that because we feel that we're working in a remote location. We don't have access to skilled labor, and that is our primary reason for doing it. We didn't ever think that we would get a cost and schedule benefit from that. But again, the sense of being a chance of being provocative, we'd be interested in seeing what data CI actually has that shows doing things as what they call modular is going to take less time and cost less. And basically, if you understand the fundamentals of project production management and operation science, you can see why that may not actually be the case. So because of all this activity, contractors see an opportunity, and many are hiring what we would call manufacturing production engineers. We have some on the line with us today, and their job is to figure out how do we industrialize what is currently going on. It's interesting to watch the manufacturing production engineers observe the guys, the project managers and engineers and vice versa, trying to figure out how to make all this work. But as Gary asked earlier, not only adding to it, what is a factory model, but does adopting a factory model and moving work off site solve the problem? And if the problem, obviously, we're saying is better performance in the form of less use of cash, lower costs, and more time. We're hearing from some of even the people on the line today. We see the time of the schedule compression. We're not necessarily seeing the cost. Again, hopefully at the end of this presentation, some of that will be vetted as to why that might not be the case. When we push back on what is a factory model, interestingly enough, a factory model to a lot of people that are involved in engineering and construction is just really standardization of products or the assets. And we're very fortunate to have a good friend of mine, Mark Reynolds, on, who is going to talk later. He's the CEO of Mace. I'd say it's probably one of the best construction management firms in the world. And Mark and I were involved with BAA 20 years ago, or 20 plus years ago, where BAA took a modular design to standard products, and there was the multi-story car park and the pier and so on and so forth. So, a lot of this is not new. People have been moving work off the construction site for a long time. I know one of the original movements was led by a guy that used to run McDonald's facilities in Europe, Richard Ogden, I believe, that started something called Build Offsite in the UK. And the objective was to get the lorries that were delivering materials into central London off the roads. Okay, again, it wasn't necessarily about cost, but it was about solving a different problem that probably assisted in. But for most people, a factory model really means we're going to have standard products or standard assets. Now, that's different than what we might call the adoption of advanced production thinking that we're going to continue to explore as this particular session goes on with all the speakers. Interestingly enough to me, though, and you just heard it, is the automotive industry that's fairly advanced is pushing for personalization through configuration. And I don't know if you've ever had the experience where you go to log on and you're just thinking that maybe you might consider buying a new car, and you start selecting all the buttons, and you get fairly confused as to this one deletes that one but adds this one, and should I get this or not? And you're trying to figure this out, and it goes on and on and on. And the point there is they understand that they need to have personalization through configuration, and that the days of the Model T, you can have any color you want as long as it's your black, isn't going to work. The customers aren't going to buy that. All right. So it's really interesting and very valuable to understand what they're doing, because they have standard platforms. They have bill of material and a bill of process that they're using to create pretty close to customizable products within reason. Okay. So, the question really is, what type of production is construction? And it could be any type of production that we want to make it, but we've made it a very specific type of production. And I think these are some of the attributes that we might agree on. It's high cost, right? So we're talking about big stuff that's expensive. We're not making pens or paper. It's one-off, mostly custom products that are built to order using a highly skilled workforce. That skill uses flexible, simple tools. That's changing a little bit, but for the most part, there's still a lot of tool belts being worn out there. A lot of tinkering and rework. A lot of tinkering and rework. I got a little project going on in my house. I'm reminded of how the person who's doing the technical work is both an architect and an engineer from 2 leading universities. And boy, do these guys they are highly skilled. We get whatever tools we need, and the architect, engineer, and the craft guys are constantly tinkering and rework. And it's amazing to watch how they want to work, no matter how hard I try to get them to move a little bit further into where we might want to be. And then there's this thing about field measure then make. So it's always best to measure it in the field and then go make it. I need to buy a little bit of stone, and the stone guy, he's convinced that unless I want to guarantee the measurements, which I'm willing to do, we better measure in the field. So what does all this really mean? It means that we're deeply rooted in craft production. Ed Pound this morning said at PPI, our research has indicated there's been no improvement in productivity since the turn of the last century. That shouldn't be surprising because we really haven't changed anything, and we're a craft-based industry, as let's say compared to what you just saw in the automotive sector. And we're organized and we operate as such. And so what does this mean? Again, some attributes: extreme amounts of fragmentation. There are endless disciplines and trades, especially in the building sector. Lots and lots of people need to be involved. I was talking to Gary earlier. He's going to go build a house. I said, you got to really watch those bathrooms and kitchens. Unbelievable amount of trades that move through there. Of course, there's lots of contractors that are involved. I mean, when you get into technology, energy, automotive, you're not talking about endless numbers of players that are involved, especially when you get into energy and automotive. Construction is just everybody on every corner has some interest, it seems, in doing something with construction. The business model is service-based versus delivering a product. Some of our speakers are going to talk about how they're looking at changing that a little bit after this presentation. It's based on cost plus profit equals price versus, let's say, a product-based industry where you start off with how much are they willing to pay and what do we need to give them, minus our cost equals our profit. All right. There's customer threats from the GC community, and so if I'm a subcontractor and I want to make a move and I want to break out and say, hey, I could take all this production capability I have, whether it's to deliver data centers because I'm a big electrical contractor, I'm a precast company, I want to be able to deliver turnkey facilities. You always have somebody who's your middleman, the broker in between the owner and you, saying, well, I'm not going to give you any other projects if you do that. Performance measures are all about productivity factor, earned hours, so on and so forth. Gary alluded to what that might look like at somewhere like Ford, where and even Mutu talked about this idea of matching takt time and cycle time, the takt time being the demand, the cycle time being the response. Liability and risk, it's incredible, at least in the US and US-based companies, how there's this complete avoidance of means and methods. The insurance companies and the attorneys that advise engineering companies and architectural companies tell them, you are not allowed, and owners, to deal around with means and methods. The process on how you do the work is the one that's fraught with all the risk. And it's just bizarre to think that you could design a precast building and not assume that you're not dictating the means and methods, right? If you say that the steel is going to be welded, you're dictating the means and methods. Lots of administration, focus on contracting and risk. I think everybody's their experience of that's involved in engineering construction. Processes and tools are designed to support craft-based work. Not a lot of precision. They don't use float in manufacturing. The takt time is 57 seconds. Cycle time needs to be 57 seconds. They don't say, hey, let's just make the takt time a minute 42, and let's shoot for a takt time of 37 seconds. But if it comes out of 4 minutes, that's cool too. We'll just submit a claim. And then all this, tying it back to Anil Seth, is that there's underlying mental models. People believe that there's a time cost trade-off or an iron triangle, and there's a lot of confusion about fundamental production concepts. But all that being said, probably the simplest way to put it, and thanks to all you guys over the last 25 years that have been saying, how do you simplify it? How do you simplify it? How do you simplify it? We propose to you that project management focuses on what, who, and when. And if you think about how you prepare a contract, who does that contract go to? When do you need them to do it? And what exactly do you want them to do? And if you put together a schedule, you do the same thing. It says, here's what needs to be done by who, when, okay? And so it's a whole world of what, who, and when. And what's missing is how and where. And so when we say there's a gap that Gary alluded to earlier, the gap is how do we do the work? Yes, the means and methods, and where do we do the work? So a little different view of that might look like this, and where this whole debate is going on between factory models, modularization, offsite, is really between fabricating or making things, delivering them, and installing them. All right, that's where the action is. I think you could go back and you could argue that when they built the Empire State Building, the Golden Gate Bridge, U.S. Steel or whomever it was at the time actually was all the way over to the process. They were processing the material to make the steel upon which they were fabricating, upon which they delivered, they installed. All this has been fragmented out, and there's many players. Of course, there's people that make steel. There's people that fabricate steel to make steel members. There's another company that delivers it. There's people that erect it. And so many players in the value chain, if you will. And this little value chain is actually pretty interesting because when you get to industrial construction, especially stuff around chemicals and oil and gas, et cetera, it is just basically one big massive steel value stream that is occurring, right? And so there could be very sophisticated valves or vessels or reactors, or it could just be a dumb piece of a structural member, but a lot of what's flowing through here is steel. So again, we've shown this probably many, many times, but really what we need to think about is that these 5 levers on how we design the product, whether again, it's just a connection or it's a complete facility, how we design the work processes to create that, and you saw some of that DFMA, Design for Manufacturing Assembly through MUTU, is really important. But it's also important to think about how we allocating our capacity and think about the contributors being labor, equipment, and space, the relationship with inventory, stocks, things that might be inbound raw materials or outbound finished goods, and most importantly, the WIP or work in process, and then finally, the relationship with variability. I think most of the people on the line understand all this, so we're not going to spend too much time, but what we can say is inventory, which is not considered in project management anywhere in the methods and processes. Inventory is a proxy for time. So if you want to predict what might happen, if you want to know what's going to happen in the schedule, if you measure the inventory, specifically the work in process, you can actually predict how long it's going to take. All right. Again, we're not going to spend too much time on this. I think most people in this call are fairly advanced. And of course, there's these relationships or curves that we talk about that are very important to what we're doing here, especially with regard to industrialized production and its application to construction. The higher the utilization, the greater the cycle time. So, it doesn't make sense to have everybody working as hard as they can. And Gary alluded to that at Ford. If you increase variability, it gets worse. Throughput will eventually get maxed out no matter how much whip you throw at it. As a matter of fact, you might not only get less out, you might drive the cycle time up, and it might take longer to do that. In the meantime, you're significantly increasing costs and the use of cash because you believe that we could actually get more done if we put more in. And so again, on the manufacturing side, what we call industrialized construction, takt time is what is the demand. Cycle time is how fast can we produce. Those are the interesting measurements. You can't change the throughput and you can't change the cycle time. All right, so any of you guys that are playing around with the industrialization of production, throughput is a measurement, cycle time is a measurement. You cannot do anything with those other than look at them and read them. All that you can play with is utilization of the capacity, management of inventory, especially the WIP, and what you're doing with variability. Okay? Time is a function, and the throughput, the amount of stuff you get out of the system, is what you're doing around capacity utilization, WIP, and management of variability. All right, so what type of production is construction? Well, a construction project's actually I don't know what the word might be, but is a whole bunch of stuff that comes together, different types of production. And a very useful tool for understanding this that you might want to take away is it's called the product process matrix, originally developed by Hayes and Wheelwright. And then Schmader here added a project to the matrix. And so what the matrix is telling you is that there's different types of production. On the bottom right is continuous flow. So if you're involved in pharmaceutical goods, refining, you're probably very well versed in continuous flow type systems or production systems, if you will. And these things make, again, food, pharmaceuticals, and processed hydrocarbons, maybe chemicals, and so on and so forth. You have line flow, which is what Mutu was alluding to and what they're doing in automotive. It's in this first example here, it's machine pace, which means that the assembly line that was not necessarily developed by Ford or invented, but was perfected by Ford, sets the pace as the work moves through the line. And then you can have a worker pace line flow. So when you see these videos of people in China that are all stacked up in these large production facilities, that would be more of a worker pace line flow. You have batch flow, where you put a bunch of stuff together and run it at once. You do call it a concrete batcher. And then you have a job shop. And so think about in a job shop, structural steel, okay? And then finally you have a project, which we might say that maybe a project sits on top of all this. And it's really about understanding what kind of production system is that particular supply chain or value stream that you're dealing with, all right? Now, for this presentation, we developed something that we thought might be interesting to you. And this was really to understand what are people actually trying to do out there. And so we put together a little spectrum here that says there is people that are trying to move work from on-site to off-site. There are people that are trying to move work from craft-based to automated, all right? And so what that might look like is these photographs here. Here we could clearly see craft-based on-site work. Somebody's working with their hands. They're installing some masonry units, brick, whatever the case may be. And now somebody's made a decision to move that kind of work off-site, and we see craft-based work in a warehouse off-site where somebody's looks to be assembling some walls or maybe a ceiling because it's a lighting fixture that's going in. But there's also a movement to automate on-site. And here we can see a robotic drilling machine that Hilti's just announced. So we have automation on site. Then we have, and this happens to be from Katera, so give proper notation to them. This is automated offsite production, all right? And so we're proposing to you that it is of value to understand what is it I'm actually trying to do. Am I trying to automate things, or am I trying to move things off-site? And you might be surprised on which one of these things is the most dangerous, if you will, to your financial health. And so we're looking to develop, and this is almost a piece of PPI research, if you will, a spectrum that puts more color on this. That says, okay, there's on-site, then there's on-site within the site boundaries. Then we start moving to off-site where we're going over the road. Then we really go to off-site where we go overseas, okay? And so because we're production guys and we think a lot about variability, obviously the further we go to the off-site, the more risk we have of variability coming into the production system. The same could be true for the craft versus automated perspective. And that is, we start off with hand tools, we move to power tools, then maybe we go to computer numerically controlled machinery tools, and then finally robotics, right? And so again, this is just trying to put a little bit more color on what this might look like. So what we're saying is you know, which direction are you moving? And you know, in hindsight, we probably should have put a poll on this, but and polled the audience. But you know, where are we moving? Are we moving work off-site? We just want to get it out of here for some reason, and we'll still do it craft-based. Which, hey, if you've been in a lot of fabrication facilities, and I've been in a lot, really all that's happening there is just moving the same work off-site. Okay. Are we, again, moving it? Are we keeping it on site, but we're automating it, or are we moving it off site and automating it? And I like to talk about the gutter king, and the gutter king to me is interesting. And think about what the gutter king's doing. And this particular instance is Gutter Magic, LLC, if you will. Gutter Magic can pull up at your house, could measure how much gutter you need for your roof, can hand you an estimate or a quotation, you can approve it, and the gutter king can knock that thing out in a few hours, drive away, and go down the road. Now, there definitely is a question on what color the gutter king can provide, but that could probably be answered in advance. Hey, I'm going to be out there at 11 o'clock today. Is there a particular color that you're interested in? Right? But the gutter king's got a mobile factory here that allows them to very quickly and efficiently create stuff using what we might call automation on site to some extent, right? Now contrast this to someone who would have a shop, and even if they had a shop, they would have to go out, field measure, create some kind of communication back to the people in the shop that are going to make the stuff, have it made, find a way to temporarily support it or short or whatever you want to do, ship it back out, and then put it in place. Okay. So I think there's something.
Todd, giving you a 4-minute call here.
Okay, perfect. So I think there's something there, and thinking through, if we go back, what the gutter king's doing and what this might all mean when we come back to this idea of modularization. All right. So clearly there's the opportunity of concurrency of work. You could be building things or making things while you're preparing the site. Okay. But you got to take into account that there's a cost to doing that. And there's a cost of inventory, which is you have to amass, handle, hold, preserve, and deal with damage, theft, meaning people are taking parts, not necessarily burglary, and then the threat of obsolescence. You also have to think about additional costs related to disassemble, reassemble, structural support, protection, and then the poor use of transport capacity. You're giving something up. And we can go all the way back to Ford, who said, look, I'm not going to ship the cars assembled, I'm going to ship the cars disassembled. All right. And what IKEA does with their flat packs, right? So again, I think what we're trying to communicate here is a word of caution to taking everything off site and attempting to fully automate things where that's not always the best practice. I'm going to go through a really quick presentation here in 2 minutes, and then I'm going to wrap it up. Okay. So if we go back 20 years ago, and Mark, you'll appreciate this, to Heathrow Terminal 5, this was a project that actually the company was taken over by a guy that ran Jaguar in the UK. So it had a high volume perspective to how they want to deliver the project, but some interesting specs, if you will: delivery to site every 30 seconds, couldn't make any difference between site 7 and 9 and 4 and 6. Single road storage was 1 day or less. The majority of work occurred after 9/11. So there was all sorts of crazy stuff going on. But the design of the production system used 2 logistics centers to buffer upstream variability to house material. And what we're able to do through using modern production, this is 20 years ago, was do the detailed engineering for the rebar in 3 days, the fabrication and assembly of cages in 2 days, and the delivery and installation in 2 days, with a total cycle time of 7 days, right? And that ability to go from 6 weeks down to 5 days, which was brought back up to 7 days, was all done in about a 2-hour planning period, okay, looking at the production system. And really quick here, finally, we also used what Mutu alluded to, this concurrent digital engineering, to design the foundation, the piles, and the factory that was going to produce the piles all simultaneously, and found that there were some issues with the machines and their ability to actually do the job, which was rectified in advance, well before anything was bought or purchased. And to be able to get to that level of detailed engineering so fast, standards were set up as a platform, if you will, on the modularization as a design requirement for the structural steel, and then the fixers were brought in early using immersive reality to figure out, can we or can we not do that work? And so finally, again, here is offsite fabrication coming into a precast facility, and you can see there's old Greg looking for stuff, the rebar is all rusted out, and moving to a capacity-based model, right, with a minimal amount of inbound materials, provided way more flexibility, a lot safer environment there. So, you know, lots of interesting activity around automation offsite. This challenges current practice due to lack of understanding how and where we do the work. And we're proposing to you that PPM as foundation of operation sciences provides the needed framework. And with that, I will hand it back.
Okay. Get my video back on. Very good. Wow. A good thing that's recorded, because there's a lot packed in there. I'm going to have to watch that one a couple of times. So now we're going to move on to hear from 3 companies back to back on what they're doing to apply industrial methods in their construction work. After they've all presented, we're going to have some time for questions. So please forward your questions to us, and we'll put them on the hot seat when they get done. So first up is Will Swearingen of Clark Pacific. Will is the Director of Manufacturing for Clark Pacific's Parking and Emerging Markets Division. In this role, he brings over 12 years of experience in complex program management, supply chain, cross-functional team leadership, and global manufacturing. Over the past 2.5 years, he has brought his outside experiences to help deliver projects requiring integrated prefabricated solutions. Prior to joining Clark Pacific, he worked at Amazon Lab, an investment banking associate at Lazard, and an engineering officer in the U.S. Army. Now, when I talked to Will, I got to learn he holds the unique distinction as the 7th consecutive member of his family that graduated from the United States Military Academy at West Point. That's impressive. Will, thank you for your service and welcome, and thanks for being here today. It's all yours.
All right, thanks, Gary, and thanks to SPS and PPI for allowing Clark Pacific to have a voice here, and I am really excited to share our journey with you today. So I'm going to structure our conversation around 3 key questions. And the first one being, why are we moving towards industrialized construction? Second, I'm going to talk about how we're doing it as an organization and what we're learning along the way last. So first up, the why. So Clark Pacific has been around, founded in 1963, and we've been a prefabricator of building components using precast as the vehicle to provide owners with schedule, cost, quality, and safety certainty. And really, until 2003, we were delivering architectural facades to projects. We saw an inflection point between 2003 and 2019 where we not only saw tremendous growth for our company through large-scale projects, as you can see some of the logos there, but we also started to understand that the market was demanding even more prefabrication that we were delivering prior to 2003. And really around in 2019, when we started to finish up our Stanford Escondido Village project, which you saw on the first opening slide, we understood and realized that our project to project approach, even though it saw tremendous growth between 2003 and 2019, it wasn't supporting the markets fast enough, and we weren't delivering the level of prefabrication that the market was desiring. And so in 2019, and really started in 2018, we decided to move from a super subcontractor into the world of world-class manufacturing and prefabricated building systems. And I'll share a little bit my presentation of what that means. But all that to say that we are very much at the beginning of what's next for Clark Pacific. We're well on our way to push from a project-based subcontractor and into product and market-based manufacturing. And it's a very exciting and interesting journey for us. So next up is the how. So our big pivot over the last decade or so was about moving from a project approach to a product approach. So part of that is standardized work and understanding the hierarchy of resources and how we integrate our teams. But within the construction industry, it's extremely important to understand the custom where it matters part of our delivery model. So site considerations, architectural and finish considerations, our capacity within our manufacturing facilities, they all lead to standardizing our work, but understanding how we deliver our product. So throughout our product delivery and product development, we understand what we can standardize, but what we continue to need to do custom to in order to create products that fit within our markets. So if you look at the inverted delivery model from the last slide, with the majority of our resources focusing on products versus project, a little bit of a breakdown of what that model looks like is the majority of our resources from a hierarchy standpoint is focused around DFMA. And then, below that is really understanding our logistics and supply chain. So our entire production system around our product focused versus our project focus. And I'll share a little bit about what that means in terms of integration with our teams. But what we're seeing is by focusing on a DFMA approach, it's injecting a manufacturing acumen into the delivery of our projects even further upstream into our design and architecture teams than we had seen before we decided to move towards a product focus. So how do we integrate our teams? Within the production system, we drive our demand from the assemble standpoint. We erect our own buildings and we trigger our demand into the manufacturing center to understand our tack times and our delivery to the field to meet our schedule. And so in the core middle of this picture, you see manufacturing. And manufacturing is the core of what we do as an organization. And it's supported by the DFMA, the facilities themselves, as well as the supply chain. And what we've done with our teams is created what we call closed loops. And so it allows the manufacturing teams and the DFMA teams, for example, to be part of a closed loop where the ultimate KPI and success metric is the product itself and not a design deliverable or a manufacturing deliverable. It's rallying a cross-functional team around a single way that drives the importance of how we deliver with this model. And we're using a Scrum framework, which, if you're familiar with it, is mainly used in the software industry, focused on 2-week sprints. And so it allows our teams to integrate daily, understand what needs to be done, balance workflow between the teams, so individual teams and members don't get bogged down and miss a delivery window. And so it's almost an operation science way to incorporate it into actually how we deliver designs into the manufacturing process. So then we step back after understanding how to integrate our teams to deliver this approach, and looked at how do we go external? How do we create products to deliver to unique markets that our customers are asking for? And so we organized our company around 3 distinct business units. So parking, facades, and structural solutions. And we've created product sets within each of those business units to deliver to the market. So the first one being Clark Park, which we launched in 2018, which we say is a parking structure delivered as a product. Facades, we launched the Infinite Facade this summer, and then we're working on what's next for Clark Pacific through further prefabrication in our structural solutions business group. So what have we learned along the way? There's a lot of important things that we're continuing to learn as we progress along this life cycle, but over the last decade, we've been really adapting how we deliver our products and how we work through our production system to take on more scope at the project level. So if you think about where we were in 2009, we were delivering a project called Munger, which was just the prefab exterior. In 2014, we moved towards what we called a Generation 1, where we developed and delivered the entire prefabricated structure of the building. For the Escondido Village project on the Stanford campus, we started to integrate glazing and kitting into that model. And then we're working on a project to deliver in 2024 that integrates even more of that interior modules into our process. So the key here, as you see the title, is our ability as a company to iterate and deliver. So each one of these steps required us to go through that whole chain that I mentioned before of how we integrate our teams, how we set up our production model, and understand how are we going to deliver that project at the schedule and cost that was set out along the way. And you know, we talk about scars a lot and developing the scars along the way. And it's about failing fast, integrating our teams, and improving. And there really are a lot of scars over these last decade as we work through the complexity of how we continue along this journey. As I showed in our production system, manufacturing is really paramount to our success. So we have 3 manufacturing facilities across Northern and Southern California that build products for one or multiple of our business units. And as you see on the left, how we utilize technology and software to deliver the work instructions to our team members is extremely important to our overall cost strategy, as well as our ability to scale the operation. And a lot of that is coming through our investment as a company and putting our resources focusing around DFMA. It's also about building a diverse workforce, and we're using operations science with PPI to help inform how we establish our manufacturing centers and our production model as a whole to be able to deliver as we further progress in prefabrication. And the last bit of learning that we're going through, especially now, is how do we integrate the software and technology into our production system? So what you see at the top is the level of our sub-assemblies that are coming into our factories, the level of support through the digital twin in our manufacturing ERP system to understand and work through the flow of our work in our factories, the project level at the bottom, our project management system, because we still deliver on projects, and with the product kind of bridging the gap between both the factory and the project. So there's a whole host of complexity within the software and technology space, and we believe it's still developing. There's a lot of innovation, investment, R&D. There's really no one-stop shop for how we deliver our work and how we're planning to deliver our work moving forward. And so, you know, just one piece of the overall complexity of what we're, you know, pushing forward with our internal resources to understand, because it's vitally important to how we deliver. So I understand I went through a lot of content pretty quickly. I want to say thank you for the opportunity to be here. I'm going to stick around for James's presentation as well and help facilitate that conversation. But if you'd like to continue the conversation of what Clark Pacific's doing, how we're thinking about things and how we're investing in the future, please feel free to take a screen grab and reach out to me and Clark Pacific. So thank you.
Thank you very much, Will. That was great. Again, provocative. It's fun to see your journey here. And now we're going to move on to our next speaker, who is Mark Reynolds. Well, Mark, we can get your video on. Here you go. So almost there. Got your screen. Now we need to get your video. Mine's in the bottom left-hand corner. I don't know where yours is.
Get there in a minute.
No pressure.
Oh, got it.
There you are. Okay. So Mark is we can see you and we can hear you. That's great. Mark is the Group Chief Executive of Mace. Since being appointed in 2013, he's overseen the company's significant revenue growth. He's constantly championed change within the industry, driving innovation to improve service excellence while ensuring Mace continues to be more productive, more efficient, and a responsible company. Mark gained his early experience in commercial and aviation sectors. He was the Deputy Program Director for the London 2012 Olympic and Paralympic Games. I bet you get some stories to tell about that. Mark is currently the member of the Construction Leadership Council responsible for Skills Workstream, Board of Director for London First, and the Northern Powerhouse Partnership, and a trustee of Land Aid. Mark, thank you for taking time. I know it's kind of late for you, but it's all yours.
Okay, thank you, and good afternoon or good morning to everyone. So as you probably worked out, I'm a Brit, and I've been working with Todd. Actually, Todd and I first met in 1997. We are a £2 billion company. We develop our own buildings. We also consult as a major program project manager. We're also a major contractor, and we operate our buildings. And what I'm going to show you is part of our business where we're bringing together all of the things that you've heard Gary, Mutu, and Will just talk about. So this company is a subsidiary company within our overall business called Mace Tech. Like anything, I have a phrase called stealing one person's idea is plagiarism, and stealing many is research. So I hope like many of you today are researching. And we're just adopting the automotive approach, very much around taking a digital twin or a full BIM digital model and taking sub-assemblies and trying to create an assembly line. So that's what we want to do, is create housing products. We can do it with anything, be it aviation piers, be it data centers, schools, hospitals, whatever, and that's our focus. And this really came about from partly from Last Planner, which is really about plan reliability, and the lessons over the last 3 or 4 years, which we've gone away from really modularization to flat platform-based solutions. And I'll explain why we've gone away from that to platform solutions. So what we want to do is design flexible products quicker, smarter, better. We want to know where be able to track every product through the process. We want to be able to buy and assemble our components. We want to have the choice where we do that and how we do that. We want to have a world-class logistics system that supports that. And ultimately, we want to be able to create a lasting legacy for our industry. And we have a purpose in our business to redefine the boundaries of ambition. And that's what we're trying to do. The image here is really much how we do this. And we want to move away from a vertically integrated organization to a value integrated organization, where we control the design, we can take any concept design and we want to create standard catalogs using federated models. We choose which we want to make or buy, and we only make anything where it's innovative and we don't have that capability or capacity elsewhere. We try to bring things together using our logistics systems, and then we are trying to minimize the amount of people on site and provide that loop around customer feedback through Operate. We have got it wrong in a number of areas, so we've gone back and looked at a technology readiness model where we actually look at investigate. So we look at ideas and filter those ideas. Any good ideas we will test. We'll do those offline. When we start developing, we'll do full-size mock-ups to make sure it works so it doesn't fail. We test that product on a small scale, and then we introduce it. And then once we're happy with it, we'll create a business unit and embed it in our business. And then we have a phrase that we like to use called innovation multipliers. And here's one of our first generation projects of a real breakthrough innovation. We call it the Rising Factory. We stole it from a project in Amsterdam, which didn't go particularly well. And our focus was how can we create plan reliability and improve cycle times. Using Todd's phrase was around the whip was our buffer, and that was to minimize plan reliability, minimize variability and give us plan reliability. Inside the big tent, it looked like this. It was a factory. We put the factory on top of the building. It was a residential story tower, 400 apartments, 8 apartments per floor, and we built a factory in there. We could work on the top deck. The next deck down, we did the cladding. And then the next deck down, we did started the floor loading and floor finish. We achieved an output of 1 floor in every 55 hours. That was including walls, floors, columns, pre-assembled risers, service modules, bathroom pods, and utility cupboards. The downside was it cost us £15 million for the 2 big tents. Took us 8 weeks on the critical path to erect it and 4 weeks on the critical path to dismantle it. So we didn't like that idea. We went to a different idea. How can we do away with the big tent? So this is what we call our East Village. Same client, same location. It was on the Olympic Park, very similar building, different facade. This is our iPhone 2. So you look at iPhone 12, we're at iPhone 2. And this has taken us 4 years. So the concept is we very much look at the BIM and taking a BIM model, but we use what we call using the federated model, we use system trees, a bit like Mutu showed. So we break everything down into the sub-assemblies, and we only look at sub-assemblies when they add value, and we look at materials and components. So we break all this down into a system tree that we can then track the sub-assemblies, the cost of sub-assemblies, the bill of materials in those sub-assemblies. And we use Autodesk Field and Glue to look at how we can, the installation on site, draw up our punch list and our life cycle testing. Key to what we do is creating this federated model, which is really important. And the federated model gives us our ability to chunk the floor plate up into a number of components, very simply structural modules. And these modules are made off site, delivered to site. This is a super slab, and let me tell you why it's a super slab. On these sub-assemblies, we can deliver the facade and the floor with 2 meter tolerance. Pretty impressive, that is, 2 meter tolerance. That gives us the ability to build a safe structure very quickly. And using a kit of parts approach around the columns, walls, service modules, utility cupboards, and bathroom pods, we can now deliver, we can make off-site through componentization. Our federated model gives us a bill of materials. A bill of materials goes straight to the factory where we can make our super slabs with all the components, all of the rebar is known, the cost of the rebar. We're getting greater certainty around the labour and efficiency and productivity. And then once they're made, they're shipped to move very close, which is next to our a prefab area, which is done by a partner. We don't actually have the manufacturing capability. We partner with someone. We rent their land. And if you look at the left of the photo, interesting, you'll see a number of slabs piled up. Todd will call that waste. I call that opportunity. And we will turn those slabs, now we've seen it, that's waste, into an opportunity to reduce the carbon content by over 30%. We don't need as much cement in those slabs because they're curing, and they don't actually need to achieve their 30-day strength until they arrive on site. So we can actually achieve work towards net zero carbon buildings by changing the approach that we're taking. But in the assembly area, we assemble all of the facades on the ground. We put the service modules in the precast slab. In our supply chain, the cladding can either come from China, it can come from Europe, but the concrete is made in our off-site facility at Brandon, and it's shipped to, in this case, London. So in the UK, there's a big agenda around levelling up and making sure work goes around the country. We erect the facade on the ground. As I said, it comes in packs, and then it's erected on the building on the ground, so thereby reducing the cost of any scaffolding, safety, and also people running up and down buildings. We track all of these components, so we monitor our sub-assemblies through floors, vertical slabs, vertical columns, cores, twin walls, facades, bathroom pods. They're all on a tracking system using Wynomia, so we know how long things take within the process of these sub-assemblies, so we can track the time from manufacture through to site installation. It's delivered to site in a normal way on the back of a low loader, and it's erected and installed. And then what we have on site is the site module going in and the prefabricated, so in the floor slab with the module going in place. We've cut down the people on site by over 60%, and it's been done much quicker. So during lockdown, this is just a snapshot of a morning, and just look at the top of the tower, the tallest tower. So at 7 AM, we put the first perimeter on the building. At 9 o'clock, that's where we were. We had nearly two sides of the building finished. This photo does a little bit of a disservice. That cladding, that floor slab going in at the time on the top left hand of the photo, we had a bit of a problem with that one. That one had to go in and then it had to come out again. So it didn't actually fit right first time. And by 2 o'clock, we'd finished the floor slab. And we work on a 7-day cycle. And this is just an image of the top slab. Oh, by the way, that cycle I showed you was actually done, as I say, 2nd of July during lockdown. Pretty impressive. We also use a tool called Lobster to photograph and track everything, so we can see our progress and get some learning from that. But actually, going back to what was said earlier about we work on a cycle time, so we don't want to do a floor any quicker than 7 days at the present time. So it's 1 day to do the floor and facade. Day 2, we do the stitching and concreting the floors together. Day 3, we bring in the walls, floors and columns. Day 4, we put up the temporary props and we do the infill between the precast walls. Day 5, we bring the utility cupboards and the bathroom pods in. And day 6 and 7, we rest, and that's our weekend. We're also looking at other areas, so other product-based solutions. So how can we avoid drywall and use pre-assembled walls, pre-service walls? How can we go quicker? how we can use bathrooms, washrooms as a componentized systems. And just one thing I add, why we've gone away from modules, is because when you put back-to-back modules, you lose space and it costs money as a net to lettable area. We've done the same with kitchens. Can we put kitchens on modules? I'm not convinced around that one at the moment. And the key thing here is why we're doing this. We're only doing this because we want to be quicker, better quality, and ultimately cheaper. At the present time, our costs are broadly the same. We know the cost of the materials, but our performance and the cost of the off-site assembly area basically makes us break even in the overall cost. But what we are getting, the speed, and if we are a developer, we're saving, let's typically take a £100 million building. We're saving around about £1.5 million in finance. And if it's a build to rent facility, we're getting new revenue of around about 2.4 to 3.6 million pounds earlier. So it's new revenue we never had. So we have two goals really. We want to turn construction into production, and we want to create a transplant factory solution that we can go and deliver this anywhere in the UK, anywhere in Europe, and ultimately anywhere in the world. So we have a phrase called construction to production, and that's the approach we're taking. So hopefully that's given you an idea. I'll put my contact details in the chat if you want to get hold of me, and happy to take any questions later. Thank you.
All right. Wow. You're pretty far down the line of improvement in applying production management to what you do. That's pretty impressive. Thank you for sharing that. That's very insightful. It's inspiring. So now we're going to move on to our final presenter here on what Goldbeck is doing with in this space. Let me introduce Max Schutz, who's the managing director of Goldbeck USA in Menlo Park, California. He's also department manager for BIM within Goldbeck Group in Germany. I think you're in Germany today, right?
That's correct.
Okay, he holds a master's in engineering and international construction management, has 10 years of experience in implementing BIM and lean methods in large construction companies around the world. Before joining Goldbeck in Germany, Maximilian worked as a researcher at the Stanford University. So welcome, Max, to the symposium. We'll look forward to what you have to say.
Thanks, Gary. Can you see me and hear me okay?
Yes, we can see and hear you just fine.
Perfect. All right, like my previous speakers, I will also circle around the 3 questions we are proposing and asking today. I've titled my presentation 50 Years of Industrializing Construction, because we have just turned 50 last year, and industrializing construction has always been our key focus since we were founded from day one, and always inspired by the automotive industry. So like I said, I'll circle around these questions as well. The why we do it, the how we do it, and the what have we learned along the way. I'd like to give the answer up front. We believe IC is the best way to really reliably deliver a high-performing building to our customer. And I'd like to stress reliably there. Quick overview of who we are. We are an end-to-end provider of commercial facilities in Europe. And we have always regarded buildings as products, which we can deliver efficiently to our clients by serving as a one-stop shop. So really from design to construction and also operation and maintenance. We have close to 80 locations all over Europe, one in Shanghai, and the office in Menlo Park is really a research office and innovation hub. We don't do operational business in the US currently. So I'd like to extend my statement here a bit. We believe it's the best way to deliver a high-performing building fast, efficient, on budget, high quality, safely and sustainably to our customer. And we think IC is the only way to really get the whole package of that statement, and don't leave anything out. Like to stress again, reliability. If you talk to our construction managers, they will tell you if you have built 5 buildings with Goldbeck, you've basically built 100, because it's always the same system. We have systemized everything from core to shell. We believe in components and an element-based approach. I absolutely concur with Todd. We don't believe in volumetric modules and modularization. We believe in flat packs and also assembly on site. I brought a little update to the productivity problem that we have in our industry, or have been having for the past decades. And we added our numbers to this graph. So as you can see, construction, you're all well aware of this graph, is down here, and the highest being manufacturing. And we are here in this blue line. And you can really see how it has been taken off. In 2003, we've been close to being average manufacturing productive, and then it took quickly off again, above 300% in terms of development productivity-wise. And that's really thanks to our systematic approach there. And the next thing, and the very important thing, is of course speed. With IC, we can really and truly be lightning fast, and we don't like to compliment ourselves, but we sure take compliments from our customers. In this case, Elon Musk, who said that, in his words, the gigafactory that we are building currently is coming together at an impossibly seeming speed, and that he was really impressed. And I think Elon can be a pretty good benchmark for expectations of speed in construction there. But it's also the foundation and a perfect foundation in that way for every innovation and even every small improvement for us. Be it BIM, be it PPM, which of course is at the core, but also for AI and robotics. Because if everything is standardized, it instantly scales to, we do over 500 projects each year. If you have a good idea, it scales to all 500. AI, you can use standardized data sets to really compare it even easier. And for robotics, you can teach it. We have been collaborating with Hildy on that robot, for example. You can teach it to a robot way easier. So you can automate even quicker. So that's our motivation basically behind why we do IC. And in order to give you an insight into how we do it, so you can already see a truss manufacturing plant in the background here. That's fully automated one-piece flow, similar to automotive industries. We really standardized the invisible and customized the visible. And I'd like to take you into our Goldbeck customer app to show you our system interactively. So we have, for example, different floor plans. If you're a customer, we can go through this, this app. And this is basically our configurator. If you go to BMW and configure your new 5 Series, this is what we do here. You can quickly go through facade types. This can be experienced in VR as well, of course. And we know this is buildable, and we know the cost behind everything here. When we go through together with a client here, and at the end of the day, he will get an estimate, even within a few hours of his project, and it's really, really accurate for a one-day estimate. Meeting rooms, for example, like everything is systematically standardized, but super flexible to fit and serve any needs. You can choose between different comfort levels within the system at Goldbeck. We always have standard, premium, and premium plus. And as I hit this configurator here, you can see in the background how your building, in this case an office building, is changing. But you can hit this, you can configure your building for anything. You just say, for the heating system, I'd like to go with the Premium Plus. You select this in the configurator, it's saved, and it will spit out an offer. And of course, the construction system is standardized as well. For example, wall elements, they are being delivered like this with the shading systems, the right color of windows already, steel and reinforced concrete in place. So everything just clicks. So we have a really high quality as well, of course, but are super fast with the method in general. So this is just a quick insight. I could go on in this configurator for hours. Anybody who's interested, of course, just reach out to me. This is how we have been applying IC. And I also would like to go towards what we have learned along the way. And in a nutshell, we have learned that you have to stand by your system. And we mean a really rock solid stand. Don't compromise. This is super important. When Orvin Goldbeck founded Goldbeck in '69, he was inspired by the automotive industry, but we started out as a steel subcontractor, and we made our way up towards the supply chain to be a total contractor and own everything. And that was the only way to be successful, to own everything. And we have also found that one can still design and build highly customized and aesthetically pleasing buildings with IC. So that we can customize the facade to anything the client wishes. And like for this example, this is a parking garage with the facade elements not being like the other. Every single is made to order. But you must stay within your system always. So we don't compromise on that. We have seen many subcontractors, many GCs fail to do that and give in and compromise. And that's when it gets messy. So you cannot leave the system. So this also means that your system must be flexible enough to serve all needs of the customer. Otherwise, it won't make any sense, right? So this is another key learning, which why we have a huge product development department for office buildings, for parking garages. Any product we offer, we have a large product development department, like the automotive industry, basically. And also key thing that we have learned, you must be involved in a project as early as possible, and talk to the client and propose. Like when he thinks about a new logistic facility, he has to call you or you call him. So that's why we have also actually technical sales engineers that can talk to the client early as possible and have a really technical background on that end. And of course, you must be able to command the supply chain. In best case, you own it. We're a very customer-centric organization. We have our customer journey up here and detailed processes mapped out, and every process behind that has sub-processes. So everything is standardized, but in a flexible way. But we own the whole thing. We only design what we build, and we only build what we design. We don't do anything else. No compromises there as well. That also means to say rather no to a client than yes, and to contracts, and also let go of contracts, possible contracts that you might be able to achieve, but it wouldn't make any sense. So that was a quick overview of why we do it, how we do it, and what we have learned. If you've for the further questions, just shoot me an email, reach out to me. My email address is right here. And I'd like to thank you, everybody.
Okay, thank you. That was excellent. And we'll ask get our video on for our last couple of presenters here as well, Mark and Will. We got some time for questions from the audience. If you got some thoughts there, please shoot them to us. So we got, I got one for you. Max, how did you deal with varying building codes in different locations? Is that all programmed into your system?
Yes, it is. So it all applies. I mean, basically, it's German, Switzerland, and Austria region. But we are further developing our building system to the European standards. So, but we have standardized everything to regional building codes because Germany is also a federalistic republic. So we have different building codes in different states. So we had to accommodate for that as well. It's all built within our product.
So another question for all three of you. What have you seen happen specifically with your safety performance for your people through this transformation that you're going through? Mark, you want to start?
Yeah, for us, I mean, it's been a huge improvement. So, you know, the accident frequency rate that we measure and the lost time incidents have dramatically by more than 50% improvement. Also, the severity is much lower, even though we're doing more manual handling. It's much lower. So it tends to be the slips, trips, and falls, which are the incidents, or when we're having traditional movement of materials of things like plasterboard, where we've got a mixture of plasterboard and service walls on the project I showed you. We actually have incidents in the traditional trades.
Yeah.
So it's trying to eliminate the traditional trades actually and move to the off-site pre-assembly approach.
But your serious injuries are dramatically less.
Severity is way down it. You know, there's so the lost time incidents and the riddles as we measure it are much less. Well, we don't have any, you know, none.
Yeah. How about you, Will?
I think we're seeing the same movement. As we're pushing towards the creation of products, I think what we're seeing just at a microcosm level is if you do the same project, let's say a parking garage, and it's designed the same way, if you do that twice, our safety performance is drastically improves from the first to the second. If you go ask the manufacturing teams to go do a parking garage and then shift toward a totally custom facades job, that's where the training aspect is extremely important. Yeah. And I would say that where we're moving further now is that part of the DFMA, that A portion of the assembly is, are we thinking about how we assemble when we design the products up front? And I think that's the next opportunity for us.
Yeah. All right, how about you, Max?
Absolutely concur. It's been going down way low, especially in comparison to more traditional approached GCs. We've seen way fewer incidents overall.
Yeah.
Also, maybe a quick word on the cost side, because Todd also asked for cost productivity wise topics. In terms of design, if you compare it to the standardized way of designing in Germany, we are 80% cheaper.
Wow.
Because we do not design to make money. We design to build buildings. And this is a huge thing.
Yeah, that is huge. Hey, going along with that, we got a great question here. And again, I ask all three of you to address it. It says, what is the tipping point for organizations to choose the path and move from construction to production? Executive light bulb moment, strategic plan, customer demand, or combination. So what turned the switch on? Max, why don't you start?
I think the switch was already flipped when we were founded. Like I said, Ordwin Goldbeck, he actually worked in the steel supplier factory of his father, and he quit because he couldn't realize his ideas because his father wouldn't let him. And then he was frustrated along the way because he was never in charge enough to make the decisions. So he made his way up the supply chain, become a GC, become a designer. We have over 1,700 architects and engineers and designers in-house. We own the design fully, like every single discipline.
Yeah.
And that was a key moment for him as well, to realize we have to own the whole thing. Otherwise, no one is going to let our system in because they won't believe us. They laugh at us.
How about you, Mark?
Yeah, my light bulb moment was in 1997 when it was Dan Jones did a speech at the BAA projects conference, and 6 months later I met Todd, and we started looking at rethinking construction, and I ended up running a business unit which allowed us to do these things. I then went on to other areas, and it wasn't until I became chief executive of MACE that I had the opportunity to then encourage others to take the lead.
Yeah.
And you need a bit of madness in this. Quite frankly, you know, when you, as I say, the jump factory cost us £15 million.
Yeah. Big guy.
I could say that was my money, so I was allowed to do it. But the orders, now, people don't see it until they believe, you know, they won't buy it until they've seen it up there. We did all of the mock-ups. They didn't buy it. We've done loads of mock-ups. It wasn't until the finished product and you sit there and say, we can do a floor week, come and have a look.
Yeah.
And they still won't buy it until they've actually seen it and touched it. And you have to have them there on the day the modules go in to see the success. So,
Excellent. How about you, Will?
So I would say we have a similar story to Goldbeck because we've always had at least one manufacturing facility that was developing precast products as a subcontractor. And as I shared in my slide, you know, the last decade, it's really about the iteration for us. So I think we're seeing a lot of, you know, venture capital investment and startups who are trying to do some sort of modularization. But the whole back end of team integration, developing your production system, and understanding that iterative process is extremely important. And I would say for us, our tipping moment was, you know, right in that 2003 timeframe, we were asked to deliver on a massive project, and we had to standardize in order to survive. Not only that project, but, you know, for our company as a whole to deliver it. And so that was really our tipping point to say, hey, we can do this now. We've invested in it. We want to carry that investment forward on future projects and continue to iterate and deliver.
Yeah, it became an imperative. Okay, we just got a little bit of time here. Got one more question. I'm going to throw it at you, Max. Somebody wants to know, your system seems to be working well for the market segment you serve. Given that, what hurdles and challenges still remain for Goldbeck?
We have a list.
Top of the mountain? Or what?
No, we have a long list that I will not be able to cover in 2 minutes. But I think a big hurdle is growth for us. So we grow organically, but still super fast, and to keep that system together. And we are very entrepreneurial driven, and we call the project manager the CEO of the project, and he has a lot of, you know, freedom. And we have to find always that balance between, you know, freedom and system. And I think the interior finishing is our Achilles heel, I think, because we own core and shell and we're super fast, but all the interior and the finishing, we do not. And there we are average. So I think that is still something.
All right, well, that's insightful, and you guys are definitely leading the way on applying industrial construction into your work, and I'm envious. I mean, again, the energy sector I come from, we're just, well, what a difference. It's very inspiring. So thank you all for your time. And now we're going to move to our wrap up, and it's going to be Will along with James Chu. So James, can you turn on your video, and everybody else but Will, shut off your video, please? And so I've already introduced Will, but I'm going to introduce James. He's a member of the Project Production Institute's Technical Committee. He's the Chief Technical Officer for Strategic Project Solutions. He's been in leading research and development of SPS knowledge, processes, and systems to support SPF's offerings since 2001. During his career, he's worked with various organizations in oil and gas, heavy industrial, civil, infrastructure, aerospace and defense, and other industries around the world, implementing project production management solutions. He earned his master's degree in civil engineering from Yonsei University in Korea, and he's got his PhD in construction engineering management from Berkeley. So I'll turn it over to you two to take it away.
All right, thanks, Gary. Thank you, Mark and Max and Will, for setting an inspiration of where the market's actually headed, as well as actually describing your journey. So what we're going to do now is actually go back to some of the original question about the industrialization, or what people are starting to call factory models. And you can actually see many of them are starting to think about from a service model to a product-led model or product-focused model. So with that, what we're going to do is now go back and say, okay, if we're going to actually apply this concept to not just industries that the speakers actually spoke about, but wider type of projects, then we actually have to think about these different 5 levers that was actually introduced sooner today, right? So there's definitely product design, process design, capacity, inventory, and variability that determined the cost, the time it takes, and the amount of cash tied up in the system. Okay. Now, although these actually speakers actually have gone a lot down their journey, as Todd actually has pointed out, most of the people that we actually hear when they actually mention factory model or industrialization is the gravitation toward the standardization. So what we're actually here to talk about for the rest of the time here is where we actually see the gap, which is the actual process design, the capacity, and the inventory and variability. Okay. So this terminology actually was getting mentioned a lot today, the digital twin. The digital twin is a system that actually has to be able to produce the behaviors that you're trying to analyze, understand, or simulate, right? So if we're actually going to look at a production system, what does a digital twin look like? So Todd actually introduced the concept of 4 verbs, 5 levers, and 3 curves. So let's actually use that as a criteria to understand whether these things actually are allowing you to do that, the 3 curves. So is that a digital twin that allows us to understand the behavior that we just talked about? Probably not. We did try, but it wasn't successful. 3D model, is it actually a robust way to actually understand the behaviors of WIP, cycle time, and throughput? Somewhat limited. Digital twin of post-it notes on the wall. Actually, no, that was actually more of an analog twin. Again, very limited way to actually understand the production system behavior. So for us, this is the nomenclature that we typically use, and we're going to actually talk about this nomenclature with using an example with Will on what we actually are looking at as a digital twin for a production system. And it actually has to have these components: an operation, routing, the queue, stock, and the capacity that allows actually these operations to take place. Okay? So the question becomes, what does an optimal factory, in quotes, look like? And the factory could be a factory that produces rebar, pipe spools, modules, right? The terminology that the industry uses, but sub-assemblies. All these things are something that's actually being produced. Even engineering documents are something that's actually being produced. So what does an actually optimal factory look like? And how do we actually do that using 5 levers? So to actually give you a little bit of more concreteness to the discussion, what we're going to do is to talk about the research projects that we're actually doing with Clark Pacific. Well, do you want to describe a little bit as to what we're looking at here?
Sure. So what you see in the top left is a 3D model rendering of a pod product that we're fabricating or looking to fabricate for an upcoming project. So it's got a concrete floor and then metal studs with drywall insulation painting. We have bathrooms and bedrooms as a part of it. So that's the left. The right side is the area within our factory that we're actually going to produce. And what you see there is the beginning stages of the mock-up process that we go through as we iterate not only our design, but also material science. And I think James will show that in another slide to illustrate how important that is. But at the bottom, you see, we're trying to understand how the design influences how we set up the factory, all within our production system while delivering with the takt time that meets our field assembly.
Okay. So thank you. So what we actually have done working together is actually taking this picture and turned it into a model. So the first step, what we're going to do is actually create a model, a map and model, and then we're going to actually simulate, analyze, and optimize what that actually looks like. And then the third step, which is the control. So the production system behaves the way we want it to behave, right? If we can't make it behave the way we want it to behave, then there's really no reason to actually do any of this stuff on the left, right? So let's actually take a look at the map and model. This is, again, using the same language that we just talked about, but again, this is just only a portion of the production system that we have. That the actual map is much larger, but this actually shows the two different configurations of a module that's actually going through the system that actually uses a common capacity, right? So the common capacity use actually what actually makes it interesting, because different variation of the product, if you actually had one type of product, it's a lot simpler. If you actually have multiple variety of actual products going through the system through the same capacity, simplest way to actually is to dedicate capacity, but you lose capacity that way, right? So the question is, how do you actually optimize both at the same time? And then the secondary one is to actually simulate, analyze. So what we've done is taken that model and working with the team are taking their actual numbers that they measured, as well as some of the assumed numbers, and actually simulating and optimizing what that production system looks like, okay? So again, actually looking at this 5 levers. So one of the things that's actually really interesting, and I think Will just alluded to it, is the relationship between the actual process designs and then the product design. Well, do you want to actually talk a little bit about what we're seeing on the picture on the left?
Yeah, so one of the subsets of our design is how do we develop a wall system that meets sound barrier considerations within the project we're doing. So that's one of the top considerations from the owner. And so we mocked up 8 different versions of it using double drywall, single drywall, specialized metal studs that's going through R&D right now. So it was our ability to say, here are 8 different variations, establish a cost for both labor and material, and also a level of risk and complexity along with each one of these. So we understand as we feed this design to our production system, we understand the overall cost. We also understand the variability as it's plugged in when we start mass production.
Can you also talk about the supply chain implications?
Sure. So one of the great pictures that floated around internally was a picture of Home Depot, which is a big box retailer for us for building supplies. Their entire drywall inventory at any given point in their store was equivalent of 2 days worth of our production. And so the delivery model for the standard construction materials requires a different supply chain than traditional construction. And so we're working through how do we develop the supply chain in a way where we're not telling a supplier, hey, I need 200,000 square feet of drywall at one time. I need 20,000 square feet a day for 14 months. And so it's a different delivery model, and there's a lot of time and energy and resources investing into the supply chain to understand how we develop those relationships with our supply base.
And also, if I'm not mistaken, one of the product configuration actually had certain components that you must procure from external source, whereas one configuration you were able to actually produce in-house and pre-punch all the holes to make the operation go a lot faster, correct?
That's correct.
Okay. Yeah, so those, as you can actually see, not only is the product actually determining the process, but vice versa, that they're requiring different operations, different equipment, and different tooling needs. Okay, so that's just one picture of how those two components actually levers actually mutually work together. Okay, and then the next one that we look at is once we actually have the information about the process, the rate on which each operation can be done, the amount of capacity, labor, equipment, and space that's available is put into the model, then we can start to see what is the right level of WIP we need to actually have in the system. And as many of our speakers actually have alluded to, work in process is the leading indicator for throughput as well as the cycle time, right? So if you actually increase the work in process unnecessarily, the chances, well, the physics actually says, operation science says your cycle time is going to increase, which means more money tied up and potential risk of actually missing your milestone dates. If you go too low on your WIP, then you're actually going to be missing your milestone dates because you can't produce enough. So understanding how much you need to actually have in the system is one of the things that Clark Pacific is figuring out. And on the right is understanding what the capacity utilization actually is for the current design. And actually, so there's actually multiple iterations going on. And what's interesting is one of the things that we actually preliminarily found right now is the tile, and the response from Eugene, one of your actually people that is actually looking at the products, that maybe we just get rid of the tile itself. So eliminate the operation as a whole, right? That's actually one option. But if that's not the case, then based on these questions, we're actually looking at different alternatives. So number one, can we meet the demand? Demand is what's actually set by the schedule of the client. Is the cash flow, work in process, and cycle time acceptable? Or do we want to actually try to actually shoot for a lower amount of cash tied up in the system? And third, one of the most important factors actually for the production system is are the bottlenecks where we want them to be, right? So anyone that's actually been involved with optimizing a production system can tell you that there will always be the bottleneck. The question is it where you want them to be? So one of the things, if the bottleneck is where you want them to be, but you actually want to go improve the capacity, or it's not where you want it to be and you want to actually move to a different location rather than actually just adding people, which increases the cost, Clark Pacific is looking at different means actually of achieving that, right? It could be chemistry, structural engineering, mechanical engineering, electrical engineering, kinesiology, construction technology, material engineering. And what we actually have is a couple of pictures that tells us how they're actually solving some of these issues or opportunities, if you would. We'll do actually, talk a little bit about this.
Yeah, so one of the components we're looking at is tape and texture drywall. And so as you see in the right-hand side picture, you see six different variants of our ability to deliver fast enough. So when you look at the production system, like James had highlighted before, we're trying to understand how do we change the game in terms of material science. And so if precast for us is the same thing, where we require overnight strengths that are different from the traditional industry where you're pouring concrete at the job site. Same here. We require a much faster dry and set time for our materials, so we can understand our process times and meet the takt time and not have a work in progress that exceeds our physical capacity as a plant. So we're investing a lot of time in understanding what materials are out there, what new materials from a supplier standpoint are coming out that we can test in order to iterate, understand our process times, and select a supply base that works and fits within our system. The picture on the left is another example where the studs get drilled into the actual precast concrete. And so you may look at that and say, well, we should have designated holes set in the precast concrete so we can just match the walls and drill it in. But when you talk to somebody who's actually doing the work, the ability and tolerances throughout the entire system to create that wall may not line up perfectly, but it still may be within tolerance of the overall scope of the wall and precast connection. And so by developing a system where you actually can screw into the precast rather than have a hole we have to align to with a fastener allows us to be much faster and higher quality because we're not spending time focused on trying to align that fastener in the perfect spot.
Okay. Thank you. So as you can actually see how a lot of different factors are actually coming into play to actually optimize the overall production system so that it's actually minimizing the amount of cash tied up in the system. It's the production system is being designed to minimize the amount of cash tied up in the system and by actually minimizing work in process and ensuring the right capacity is actually allocated to the right place. So the next step is to actually, again, as we talked about, is to ensure that the production system behaves the way we want it to behave, okay? So to actually demonstrate that, what does it actually mean to actually have it controlled? It's to actually have, how do we actually have parts that we need at the right time and not the ones that we don't need, right? And it's not just actually talking about the delivery, but it's also about making, right? And then if we actually go further back, maybe it's actually about engineering as well. Okay? In order to do that, it's not just about optimizing how we make something, but it's about how do we synchronize. To synchronize the actual installation with the actual supply flow that we just actually looked at. So that actually has to come into play. Otherwise, we might end up creating stuff that efficiently to actually have cash tied up at these stock points between delivery and installation, right? So as Todd actually had talked about as an example in the previous session, is someone actually spent optimizing how they actually drill wells, and then that actually had increased amount of cash inventory that actually sat here, for example, and had tied up a bunch of cash that they didn't actually need to do so. Again, so what we have to do is make sure that the left and the right side actually is synchronized. So to do that, the vision is, so you actually have the installation demand that actually has the specific modules that are actually attached that provides the prioritized fabrication demand that signals the production system to produce what they need so that they can actually deliver and actually have it installed. All of this actually working in sync, right? So if there's actually something that's actually speeding up, you can take advantage of it. If something actually is slowing down, we're not creating unnecessary whip in the system. So we want to be able to create to control an agile production system that doesn't have whip blow up or whip deterioration. Okay. Okay. And then start actually measuring things that are production control related analytics. So things like throughput, cycle time, whip, and looking at all lines of balances of the activities that are actually occurring. Right? Rather than typical project management metrics that might be percent complete, CPI, cost performance index, and schedule performance index. So if you're actually managing a production system and you want to actually understand what actions you need to take, then what you want to be actually looking for is the actual metrics that's associated with production control. So once you actually have that, what it does is it allows you to actually provide data capture and input back into the model, so that this actually becomes a system that's actually improved, that allows you actually to continuously improve, right? And some of the things I think that we're discussing is, if you can actually automate a lot of these things, then again, I think we're actually a step closer to what we talked about is intelligent production, where it's a self-optimizing system. Okay. So one of the things that we actually seen, and I think Todd actually brought it up a little bit earlier, is I think you actually have a choice. You can actually take the approach of a trial and error, right? And I think we actually see a lot of that actually in the industry. And when we actually watch the trial and error, they say, well, we're actually doing continuous improvement. But if there is a way to figure out and design something and then control to it, why even do a trial and error? Because you actually have a good basis to start with. Okay? So whether you take the trial and error approach when you actually are adopting industrialization or design and control approach, I believe the choice is yours. Okay. Okay, that's all we actually had, and I think we actually have a few minutes for questions.
Yes, we do. Thank you. So we're looking for some questions from the audience here. We've got about 7 minutes, so please feel free to light them up here. Maybe I'll get the ball rolling. So how long are you into this process of getting your lines of balance worked out and optimizing the system?
Well, so we're a couple weeks into understanding our process and finding a lot of these interesting data points that James highlighted. I think we're 8 or 9 months out from mass production. So we're in a place where you saw those 8 pictures of the wall systems. We're actually using that mock-up to change our design in real time. And so I think it's one of those things in the construction engineering industry where, a lot of times it's why I got to get it 100% before we actually test it. And we're changing that model by saying, give me the 8 different versions of what you want to do, and we'll test all of them, and then we'll provide the options and the feedback. So we call them one-way doors. We don't walk through a one-way door and put ourselves in a bad spot and then have to live with it over the course of the 14-month production cycle.
Yeah. So we're starting to get some great questions here. This all sounds logical. What's the biggest mindset bottleneck you found with your colleagues?
So, so I'm coming from the world of consumer electronics. So my mindset was high volume. We did 10,000 prototypes before we went into mass production, tweaked everything, changed every design to delight our customers. And Clark Pacific's, the journey that I talked about was very much an engineering company that got thrust into the 2000s with large scale projects that had to make, that made engineers have to think like manufacturers. And I would say we're still in that journey of understanding how do we as a company create a collective mindset, bring in people who have a different view of what production, manufacturing, operations looks like, inject that in a positive way and move forward. And I think that this product that we're working at has all those elements, right? There's a design element, there's a delivery element, there's a manufacturing element, there's an R&D element, and it's forcing that team integration that I talked about, which is very unique for us because it used to be engineering delivers to manufacturing, manufacturing delivers to the field. Now it's a loop of cross-functional teams that are delivering it together.
And you're in this process of converting from a push approach to an entirely pull approach. That's a big shift. And along with that, another great question. James mentioned using lines of balance scheduling for his analysis. LOB is such a powerful tool. In your experience, why do you think LOB is not used more often by US-based construction companies?
Oh, that's a great question, and thank you for asking that. Number one, I think what we're actually doing is not using line of balance to schedule, and I think some people are trying to actually do that. What we're actually doing is observing the line of balance as an output to understand whether there is a discrepancy between the actual rate that we're actually getting from the model rate that we are actually planning for. Okay, so that's what we're actually trying to understand. That's what we're actually using. Line of balance scheduling, again, is, as you said, it's not something that's actually a lot of US companies use, but what we're actually doing here is understanding the rate of what's actually being done using line of balance.
Sure. And so why aren't more people using it? It's powerful.
As a depiction of what you're actually getting, it's a great, powerful tool. The only challenge is, number one, you need to actually have your production system defined in order to be able to map that, right? And if you don't actually have your production system mapped, then I think people typically actually have an S-curve, and those two, they believe that they're synonymous.
Yeah, I think you're spot on. Traditional project controls don't provide you any of that information, don't provide you any flow information, and only provide you earned value information. So it's just an apple and an orange. And I think the historical practice is project controls, not production management. And so that's the shift we're trying to make, huh? But when you see it, it's pretty compelling. So maybe seeing is believing, and hopefully we got a few more believers here after participating today.
And what's interesting, I think Martin actually asked about the mind shift. And that's actually one thing to actually talk about. It's always actually interesting to work closely with the people that are actually trying to implement this type of an approach and challenge. Because when we actually are looking at different alternatives, we're actually looking for some data, the return and the feedback loop cycle is probably within hours.
Yeah.
Right. And when we actually had to introduce this concept, we actually had, we should say, all of your top management actually in one room, spending whole day going through the basics of the operations science, that they actually wanted to get around the common language. And it actually involved two CEOs actually sitting there for a whole day. And so that's actually that was like pretty interesting. It tells us that they're really trying to do something.
I want to thank everybody again for all your insight, sharing so freely and talking candidly. And we're going to close this segment off and invite you all back in 15 minutes for our final wrap up, where we wrestle with some of those frequently asked questions of how project production management fits in with conventional project practices. So thank you again.
Thank you.